Hey, Savio here. I thought today I would share a little devlog on my zombies and kind of how the zombie systems are built in the game and what I plan on doing with them in the future. Um, zombies have been through a few different iterations, and I did want to show on Fab the original assets that I used to start creating this system. Um, there is a person on Fab, WellWeldedGames. He makes really good assets. He's got quite a few of them. The casual zombie, the dismemberable zombie pack. I purchased the zombie biker plus dismemberment system, which was used for a lot of the stuff, including the zombie art, which I will probably add more zombies in the future. The nice thing about this system is the way the zombies are modeled. And I'm not a character artist. I'm more of an environment artist and level designer. More of a level designer now. I do a lot less art. So finding something that worked for the system I wanted to create was very useful. And yeah, you can see the dismembering is actually fairly similar to how this system originated. Mainly because that's how I wanted the parts to break off and stuff, and this just worked for me. So zombies that come in the paid versions are a little bit more complex. They have upper and lower arms and upper and lower legs, and more high res textures and models and stuff like that. Where the light version, it's essentially the code is the same as the paid versions, but the and he still provides the dismemberable system, which is great. So you can kind of learn off of that. But this zombie only has legs, arms, and head. It doesn't have upper and lower parts. So it's a little bit more basic. Now, my system, I wanted to use both those zombies through the same system, so I decided to create two different types of zombies, and I have a zombie blueprint here, which inherits from my zombie character done in C++. And essentially, all this one does is it just handles extra uh, blueprint implementable events to do things that pretty much a lot easier in blueprints or something that I might have wanted to do differently in other zombies later on. So one of the main ones is timelines. I don't like doing timelines in C++, so having a function I could override in blueprints and call here, which dissolves the zombie, it just modifies some materials. So handling the timeline in blueprints is a lot easier. I can, adjust curves and stuff like that a lot easier with it visually there. So the zombie blueprint, it has a few unique things about it. In the base blueprint, I don't have any meshes or anything assigned because I don't actually spawn this one into the world. So I have a child of BP zombie, and this one has a few different things assigned. So I have a dismember component, which is similar to the one provided in the dismember system here. But I've recreated everything in C++, and I have changed quite a few things in how they behave. So it has a structure of uh, dismember definitions, an array of these structures, and each one of them has skeletal mesh for the replacement when a limb breaks off, or replacement mesh when the limb breaks off, health values, break health, the bone name to break off when body part's been dismembered. So that if you've messed around with the dismember system here, um, the structure of the component is actually very similar. Um, I do have optional hit effect systems as well, where it'll choose a random one. Um, and impulse and stuff like that is pretty much the same. I also have a health multiplier because I modify these values every round. So because it's a wave survival game, adding some difficulty and multipliers for certain values like health on each of the components was kind of important to me. So that's kind of how I adjust difficulty of the zombies. At least for now, it's really only the health multiplier. I also do damage multipliers, but all that stuff is handled throughout inside the anim montage, because the anim montage handles things like melee stuff for the zombies. So if I open up my zombie animation, one of the attacks here, I have anim notifies that handle the melee um, damage and stuff like that, which in here it will kind of modify the damage um, based on a multiplier set by the current round that our current wave, if you want to call it that. So yeah, that's a little introduction to the zombies. And now I kind of want to take you through all the iterations I went through. So the base zombie pack comes with a dismember component, which I slightly modified in blueprints, but not really anything crazy. So the main function is this owner damage function. And in the blueprint zombie that's provided with the oh sorry, wrong one. With the blueprint zombie that's provided with the dismember system, they have point damage event like this, which iterates through a switch based on this owner damage function. It gets the component that was damaged. And if it's valid, it switches through those. So each index of the array inside dismemberment data is important here because it will use the indexes rather than kind of searching or evaluating names or anything like that. I just make sure that all the indexes for each part is always the same. Um, but that's besides the point. It will then evaluate if the body part was dismembered. So this just really sets bools so that the animation blueprint can do different things, like play different animations when like if both legs are damaged, he goes into a crawl mode and stuff like that. So then I adjust the max speed based on which parts are dismembered, and if the zombie's dead, then I simulate physics on the body and disable collision on the capsule to make sure that you don't run into the capsule, but it's just going to be physics simulation on the mesh. So this is kind of the original system, and if you guys use the dismember system here, you'll see that. And then inside their dismember component, they find they do a search through the components we inputted, which are an array of the skeletal meshes here. And this array is set based on these all these child components here that are dismemberable or considered dismemberable. And then so it tries to find that based on the tag that was hit. So the influenced bones that are assigned here are trigger bones. They are named in the original component. They are used to search through if this component was hit. So if I hit the head, neck, or spine, then it says, okay, you hit the head, and the actual bone to break off will be the head. So it's not gonna, if I hit the neck, it's not gonna break off the neck. It's gonna say, okay, you hit the head, let's break off the head bone. Um, and that's important because of where the meshes actually separate. So if I grab my head bone here, you'll see the reason I want to break off the head is because that's where the skinning actually separates on the broken meshes. So this part will be remaining on the zombie, and this part will fall off and simulate physics. So that's kind of how that happens. And they only simulate physics and break off if should trauma be simulated is true. That's another important one that's handled inside owner damage, which I'll show. Um, but with the body is really the only part that we don't simulate trauma because it's the kind of parent component. It's what's assigned to the actual character mesh. We don't want to simulate physics on that or break off any of the bones from that because um, that part is going to be used as the pose leader for every other component. So this is the only one that's not simulating trauma, and the body or character mesh only ever gets simulated uh, if the zombie dies. And then he kind of just falls to the ground, and I stop animations and stuff like that too. So yeah, that's kind of an introduction on the zombie getting damaged. After it finds which component it hit, it uses that to find a body part to replace, which searches through the dismember data. Um, and this dismember data, if it finds one of the body parts based on the bone name, and the damage it kind of evaluates damage as well. So if the current health is less than 0, it will dismember the part unless it was already 0 upon entering the function. Then it kind of ignores it as it's already a dismembered part. So if it should be dismembered, then I set the mesh. So I change it from the regular body part to the normal body part. This already exists in the example provided by WellWeldedGames as well. Um, then I simulate physics on that body based on the bone that was hit. So I only simulate it. I don't simulate it on the whole character mesh, just the part that we broke off or were about to break off. So then the important part happens. So break constraint. Now, break constraint was a little bit confusing to me at first, and I tried a couple different methods to optimize the system, which I'll get to next. But break constraint, essentially what it does, it says break constraint off of a gore mesh. My original assumption of what it did was broke the actual bone name off of the mesh, which that isn't the case. What it actually does is it breaks the physics body off of the physics body for the mesh. So because I'm getting index 0 here, index 0 in this case is always the body. So it's always going to be the character mesh itself. The break constraint, the reason it happens on the body and not the component that we're actually hitting, um, and the components that we're actually searching through within dismembered component, is because these components are already set to have their pose leader as the character mesh, which is the body in this case. So we're breaking it off of the body. Um, and because we're breaking it off the body and that component's a pose leader, it's going to follow. Um, so because this only breaks off the physics body and not the bone itself, we can reuse things. And that was kind of the thing that I got stuck in is I'm like, okay, I don't want to optimize the zombies. I don't want to destroy them. I want to reset their physics state and their meshes and um, their health and their data and stuff like that. Because spawning actors is obviously one of the most expensive things in Unreal. Um, so we don't want to be doing that all the time with hundreds of zombies if we're gonna have hundreds of zombies. So after breaking the constraint, I spawn a system, and then the important part happens where I want to reset the zombie stuff. So this is something not included in the example, and it was something very important to my wave survival system because I don't want to continually be destroying and respawning zombies, which is how the example kind of behaves. And even in the demo, I believe there's, oh no, maybe it's just in the level blueprint. Um, in the level blueprint of the example, they do show just kind of the zombies respawning. And all it's doing is spawn actor, and then when they die, it's just destroying them. Um, so it's just using this node, and it's continually respawning them. It's not trying to reuse everything or reset the zombies when they die, which is what I do in my new system. So in blueprints, sorry, this was kind of my blueprint tests prototype zombie. I have a interface event called reset, which attempted to before you see it's kind of a mess right now. It attempted to reset all the zombie mesh components. So I attempted to reset dismemberment, which just resets all the bools and activates the dismember component. Um, then I would set the actor position to kind of get it out of the way. I'd stop the behavior, so state tree in this case is what I'm using. Um, and then on begin play, uh, the next time the zombie was spawned, rather than using regular begin play, I made my own. That way, when I respawned the zombie, I could just call this, since this would only get called when the zombie was initially spawned. So I destroyed all the skeletal meshes, which would be the um, the components here, the body parts, and then I would reset the zombie skeleton. Which in this, I was actually recreating the skeletal mesh components for the body, the head, and all the parts. So um, rather than respawning an actor, I was just recreating the skeletal mesh components for the body parts. And the reason I was doing that is because I could never figure out how to properly reset physics state for break the broken constraints. Um, what would happen is that I would break off a limb. So let's say for example, I broke off the calf, um, and I broke off the arm or something. Um, it would dismember them. It would set the skinned asset to the broken part, which would be a different version of this part. So there's up arms and then there's up arm damaged. So you can see the damaged ones, they're actually split. So when I reset the zombie, I want to reset it back to this. Um, and I want to make sure physics is also reset. So um, I I would I got to the point where everything was resetting except for physics. And what would happen is the arm, upon resetting, physics would never reset. So it would stop simulating physics on the whole body, and these would look fine upon resetting. But if I broke off a different arm, so let's say I break off the right arm after resetting the zombie, um, all the parts that were previously broken off, so I previously said I would break off the calf and the left arm here, um, and then after reset, I would break off a different piece. These parts that were previously or simulated would be simulated again, even without them being broken in the dismember component. So I know it's kind of hard to explain, um, and I can't really show it anymore because I've already fixed the issue. But um, what would happen is these parts would fall to the ground, and the skin, because the mesh didn't change, because we essentially the second time around we never dismembered that arm, we dismembered this arm, but this arm would still fall to the ground. So the skin would be stretched because the mesh never got changed and the bone never got broken in the correct spot, so it would just fall. um, and it would only happen when we simulated physics on these bodies, because it would say, okay, um, there's a bone simulating physics on this body, but all these other ones were previously simulating physics. So because something is simulating physics, everything that previously would simulate physics. Kind of hard to explain. Anyways, how I ended up fixing it and moving away from the system that destroyed components and recreated components. I wanted to really find a method that wouldn't destroy any components or re-add components during runtime. I only wanted to create them once and forget them and just be able to reassign the meshes to default and reset the physics state, which I tried. I tried doing with a few different methods, and Um, yeah, I tried it in Blueprints to the point where I couldn't anymore, and then I started creating things in C++ with what was already working. So that's where I'm at now. And now, instead of there being a blueprint zombie with parent character, I have zombie with parent zombie character. And the zombie character, I pretty much took everything that was in the blueprint zombie and everything that was in the dismember component and made it in C++. So here's how I did it. Let's close up these. You can see with my new one, I have a lot less stuff in here. So I'm actually just rewarding stats to Steam um, in Blueprints, and then I'm calling an interface event after rewarding the stats, which I could probably do this in C++ as well, but I'm doing this in Blueprints just so this happens first. And um, this should also go here. I'll do that later. Um, Begin play sets the timeline speed for dissolving, so that's just I have dissolve time float, which this happens on death. As I previously mentioned at the start, I just like handling timelines and blueprints, so that was the reason for this. And it just modifies an alpha on the material of the zombies using material instance, dynamic material instances. It just sets a scalar parameter, which just kind of dissolves the zombie. I'll show that after. This one, the reason I'm handling this in Blueprints is because I don't create the state tree component in Blueprints. I haven't decided if I want to keep the state tree or just move the logic directly into the character, because I'm essentially just attacking and moving to a location, so I don't need too much complex logic. But I created this just because I like state trees. Um, so in Blueprints, I just enable and disable the state tree. I do this when he resets and when he spawns. So I restart the logic when he spawns, and I stop the logic when he dies. Um, that way that stuff's not running in the background. So this is all that's pretty much in the blueprint zombie. If I open up the zombie character, which it should have just opened, um, this is the zombie character in C++ now. So if you guys are familiar with blueprints and you don't know anything about C++, that's okay. But I essentially took everything that I had in blueprints and moved it here. So I create all my variables, my bools for dismemberment, my mesh components, um, private functions that are just handled in C++, construction and begin play. I do add the dismember component and the navigation invoker component in C++ because this is used on all the zombies. You know it will be, and um, the dismember component I now have created in C++ as well, so I'll show that. That's all in here. Um, and yeah, these are pretty much just all the variables, public variables, attack montages, spawn montages, dissolve data, anim instance classes, zombie types. I have data tables for wave data, which modifies things like the max walk speeds, and damage and health and stuff like that for each round. Um, this was just to easily set the mesh transform, so I didn't have to do that blueprints. I have a default character mesh. I have a character mesh collision profile, which is defaulted just a default character mesh collision profile for now. I didn't really need additional one. Um, then I have the meshes. So these aren't the mesh components, but these are actually the meshes being assigned to the mesh components, like the head and all the other body parts. Couple bools. I have some getter functions for getting all the skeletal meshes. So this will retrieve an array of skeletal mesh components, which I'll show after. Um, Getting attack montages. Is the zombie dead? A bunch of just handy getter functions. Updating zombie speeds. That happens when I update the wave data. This is the uh, called in blueprints here. This is the on dissolve timeline update, which just modifies the material dynamic, dynamic material instances for the zombie to dissolve it. Um, then I have on point damage taken multicast delegates for handling when I receive point damage or radial damage. Then these events just call handle damage because it essentially does the same thing. So handle damage will um, then call the stuff that happens inside previously shown. Oh, uh, oh, wrong one. Apologies. It pretty much does all this. That's what handle damage does because the original zombie just handles point damage. So I wanted to handle multiple different damage delegates. So I just made a single handle damage event that handles all of this. Um, then I have events for each of the body parts. So these ones here are created. That's what is happening with all these functions. So body, head, left arm, right arm. Um, and then I have an event for on zombie death, and I have similar events for an interface. So I have a zombie interface that handles things I showed in my blueprint prototype zombie. So it's pretty much zombie begin play here, plays a montage, resets zombie data, resets things like the skeletal meshes, and in the new iteration resets physics states and stuff. So the new final version doesn't destroy anything, doesn't destroy any components, doesn't destroy the zombie actor. Once the zombie actor slash character has been created, it never gets destroyed. It either lives in the zombie pool waiting to be spawned, or it is reset and spawned and reused. So I've kind of balanced each wave to make sure that um, higher waves, higher rounds never use less zombies than previously used of the same type. So if I spawn 10 walkers, it's never going to spawn less than 10 walkers in future rounds. It's always going to spawn 10 or more to make sure that I'm not holding on to zombies I don't need. Um, so yeah, that's kind of what happens in blueprints. And I have similar functions for retrieving getter functions that I've created above, or just retrieving private variables that didn't really want accessible except through an interface in the zombie. So moving into the more complex stuff with the zombie character, um, all I do now is I create the skeletal mesh components and attach them to the character mesh on construct after creating my dismember and navigation components. On construction, um, I loop through, or sorry, I don't loop through. I check to see if the character mesh, the default one, is valid because I never destroy that anymore now. I use that as my body, and I use that as my pose leader. So if I have a valid character mesh, which I always should in this case, then I check to see if it's an advanced zombie. So I have a bool, which is just default editable. It's never changed on runtime. It's just used to check if we have our lower arms and legs. So, like I was saying at the start, the light zombie version only has uh, legs, arms, and head. It doesn't have lower and upper legs and arms. Um, So that's what I have is advanced zombie. So if it's an advanced zombie, I include those lower arms and lower legs. And it does require now that the dismember definitions have equal array number. So you have to have enough elements in your dismember component. So this one, for example, only has 6, which means um, it's going to assume it's a basic zombie and it doesn't have those lower and upper parts. It just has one part for the legs, or each leg, and one part for each arm, and then a head. So if I do have all those advanced parts assigned, then it will, this just assigns tags. And the tags are used in the dismember component to decide which bone and constraint to break off, which I kind of showed in the original dismember component here. So that will loop through all the trigger bones, um, which I now call influenced bones here. And it'll set the tags on that mesh component. So this is just if it's not an advanced zombie, or if I don't have 10. What it does is it checks to see if the dismember definitions has 6 or more elements. So as I was showing here, the 6 elements here, this is a basic zombie. Um, it would successfully enter this and assign all the tags because I have at least 6 of them assigned. And if it's an advanced zombie, I still assign these because advanced zombies also need the same parts as a basic zombie would have. I assign the anim instance class, so the animation blueprint, and then I initialize the zombie. So initialize the zombie, this not only happens on construction, but it happens on my zombie begin play. And this assigns all the meshes. It assigns the collision profiles, which for the body is the mesh collision profile, which is just the character mesh, default character mesh collision profile. The all the other body parts have no collision because they have the character mesh set as their pose leader. So this will already have collision. The parts that are used as the pose leaders don't ever need collision. Um, they're just used visually and for animation purposes. If it's an advanced zombie, that's it'll only assign these meshes, reset them, or assign them if it's an advanced zombie. Um, then I assign my array of dismemberable components. So I reinitialize that array. So the array that is inputted into the owner damage function in the dismember component is set on construction, and also, or I guess, yeah, construction when I initialize a zombie. So every time I initialize a zombie and reassign all my components, I just refresh the array to make sure that if anything got messed up, that there's no old references or anything. The deactivate zombie. Works hand in hand with initialize zombie and was kind of before where I would previously in blueprints destroy all the components and reconstruct them. So now what happens is this only gets called when the zombie dies. I call reset zombie. So the zombie dies, he simulates physics, falls to the ground, and then after a few seconds he dissolves. That's where I use that timeline. At the end of that timeline, if you didn't notice, I call zombie reset. Zombie reset, what it does is it hides the zombie, disables collision on the zombie and stuff, and it returns it to the zombie pool that I have. And it says, hey, you're available now. It also calls deactivate zombie, which sets all the meshes to null. It simulates physics, it deactivates simulate physics on everything, all the components. It also, very important, empties override materials. Because I am in the dismember component changing the meshes, but I'm using the same skeleton. I'm not changing the skeleton at all. I'm just changing the mesh. Um, it doesn't actually change the materials of that mesh. It just assigns override materials. So in order for you to reset the meshes properly, you need to empty the override materials. Otherwise, When I reinitialize the zombie and reassign the head mesh to the head, it's going to hold on to the materials that were on the broken head. So the broken head gets assigned in the dismember component, which I'll show after. And the broken head obviously has some different materials on it. But when that gets assigned, because it's sharing the same skeleton, they're just assigned as override materials. And when resetting those, you have to clear them. Otherwise, my head mesh that's not broken will be using the materials that were used on the broken head. I'll show that in the dismember component after. So, yeah, the two important things were nullifying the mesh and emptying override materials. The reason nullifying the mesh is important as well, before resetting them back to their defaults, is because of physics bodies. So simulating the physics to false only does so much. If I don't re completely nullify the skeletal mesh and then reassign it afterwards, then it will not reset physics properly. I'm not sure if there's something around this, but I noticed that the parts that were previously dismembered, even if I would assign the skeletal mesh to default, um, certain bones would still be simulating physics and broken. So it wouldn't reconstruct my broken constraints properly. So nullifying the mesh first and then reassigning the body mesh, that reset the physics body on that mesh, which is important. And it's a lot less expensive than destroying the skeletal mesh and recreating that component, which is what I was previously doing. I can actually show in previous iterations of my code. This is source tree. If you guys are familiar. I had this. So I would initialize zombie components, assigning collision. Um, and that was happening here. So I did pretty much the same thing. On spawn zombie, I would destroy all my skeletal meshes using that get skeletal meshes function, which would return an array of skeletal mesh components of all my body parts. It would destroy them all, and then it would recreate those components, reset up, register the component. It did a lot of extra things that were unneeded. Where now I only reassign the meshes, reset materials, reset physics, and I reuse these parts. So zombie begin play, this isn't regular begin play. This is an interface event through the zombie interface, which is called after I spawn the zombie. And this is used so that I can spawn existing zombies without having to recall begin play itself. It's essentially my own begin play, which updates the zombie type. I guess I don't really need to do this. Oh, sorry. Yes, the spawn. Actually, I do need to do this. The spawn type is different from the zombie type. The spawn type I use to select a montage to play when spawning. So he's either spawning from the ground or he's spawning from a wall, like he's coming out of a window or something like that. So I'll play different montages based on the enum that I've created zombie spawn type. And this just stores it in the zombie itself, so I can use it later if I need to. You'll see that zombie begin play, I initialize the zombie. So initialize the zombie is what assigns the default meshes, the collision profile, resets transforms, and sets the pose leader of all the components, not the actual mesh itself, because that's our pose leader. So back here, after initializing the zombie, this is where I play the spawn montage. So it uses the spawn type to decide which montage to play. So I guess I don't really need the variable here. I could probably just use the input zombie spawn type here. Anyways, Uh, I unhide the zombie right after playing the montage. That was important because sometimes it would be like in T pose for a frame. So I just wait, set timer for next tick directly in here, and it just calls set hidden in game rather than previously where I've commented out. I was just setting it hidden. I noticed it would for a split frame, you could see the zombie in T pose before he'd actually play the montage. So that fixed that. Then this is a interface event that's called through an anim notify. So inside all my spawn montages for the zombies, I just call on zombie spawned. It happens right near the end of the montage, where it starts the state tree. So the state tree is actually not running until after the spawn montage is played. Kind of smart. Don't need behavior logic or him chasing the player when he's spawning. So I also have a bool is spawn finished, which is used to kind of gate certain logic inside the state tree. Um, so uh, if the if the zombie is not finished spawning, he's also not available to the zombie pool, and he is not considered dead, but he's pretty much in a dead state, um, where the behavior and the zombie manager can't really do anything with the zombie. If this is true, or sorry, if this is false, so during the time that he's spawning, um, so yeah, that happens shortly before the spawn montage is complete. Update wave data. That updates things like the damage, the max walk speeds, and health based on the current wave that we're in. Which yeah updates max speeds. Then I do a zombie reset. So zombie reset is called from our blueprints here. Um, it doesn't have to be called from blueprints, but the reason I do that is so it can call after the zombie disappears, so after he's dissolved, so upon finishing the timeline there. And what this does is it says, is spawn finished false? Is the actor hidden? Yes. I disable collision. I disable the behavior tree. I reset the dissolve parameters to 1. So because the zombie's already hidden, I just decided that resetting the materials back to visible was completely valid in this here because the whole actor's already hidden, so you won't see the mesh anyways. I could have done this either here or on zombie begin play. Um, then I reset dismember data. So I'll show this after, but essentially this just resets all the dismember data because I'm modifying the health values and stuff in there. Um, and then I deactivate the zombie. So deactivating the zombie is where I disable physics and yeah, I kind of showed this function. So it nullifies all the meshes, empties the material overrides, and that's pretty much it. So after resetting all of that stuff, um, I reset the zombie data, which sets all the body parts back to false. And this will pretty much say, hey, the zombie's not dead anymore. He's waiting in the pool. He's available. He's not pending reset anymore. And this happens at the very end of zombie reset. And it kind of waits 0.33 seconds after deactivating to kind of give it a second to nullify and reset physics and stuff, just in case. When I have 100 zombies in there, it might need that little bit of wiggle room before resetting things back to false. So um, I suppose this could also be called and deactivate zombie, but there might be a time later on why I want to deactivate zombie without resetting zombie data afterwards. So yeah, that's the main part of resetting the zombie and initializing the zombie meshes. And the major things that people will probably run into issues with, which I did, were making sure to nullify the mesh and empty materials if you're changing the skeletal mesh to like a different broken or dismembered part. So I don't want to get into the specifics of everything else, as most other things are pretty much the same as they were in blueprints. Yeah, there's lots of stuff here, about 1,000, almost 1,000 lines of code here. So I don't want to go through everything, but I will go through the dismemberment component because um, that's a big part of why um, the meshes need to be nullified, physics needs to be reset, and override materials need to be cleared. Is because on owner damage, so owner damage happens in the blueprint version right here inside the dismemberment component. It receives our dismemberment components, which this array is set by all the uh, child components, body parts. So this is pretty much the same thing that happens in blueprints. What I do differently to make sure I can reuse these components is, and because I'm having this sit in the pool, is I check to make sure the component's active. So this is an actor component, and this is a default function from actor component is active. Used in blueprints, it's the same thing. So is active, straight from active component. So I don't run any of this owner damage stuff unless the component's active, because when I reset them, I deactivate the component to make sure none of this can run. Or if later on someone decides to create a child actor with, tick running or something like that, evaluating something on a timer, well, I guess timers will still run if it's deactivated, but tick won't. Certain things won't run and will be disabled when the component's deactivated. So I like using the default is active to gate certain things. So if the component's active, do I do this? Otherwise, I return everything null or none, and I do print an error log. So if it is active, I spawn a hit effect, which is the blood effect you see, and then I find component to dismember, which this loops through all my dismember components, um, which is just an input variable similar to here. I loop through all of them and I check to see if the tag inputted into the function, uh, or if the component, sorry, contains the tag that we inputted into the function. Otherwise, I return null. So the first one it finds returns that component. If that component hit is valid, so coming from which is a skeletal mesh component, coming from the find mesh component to dismember here, because this function is not void, it returns a skeletal mesh component. So if it's found successfully, then we initialize our variables for the return values of our next function, find body part to replace. What this does is it loops through all our dismemberment definitions, tries to find um, one of the definitions that contains the bone name that we hit, and it initializes two variables, current health, and if the component was already dismembered. So it determines if the component was already dismembered based on if the health was already 0 upon entering this function. And then only after do we subtract the damage from the health. So in this case, the health can actually go below 0, but if it's below 0 upon initially entering this function, it's already considered was dismembered. And then I grab the constraint to break from the dismembered definition. And if it wasn't already dismembered and the current health now is less than or equal to break health, so break health is it's not 0. Um, it's usually between a value of like 10 and 25% of what the normal health is. So once it's about 25% of the normal health, let's say, it defines the bool should break, which is the output variable. So should dismember is also a output variable. That's also determined if it was not already dismembered and current health is now less than or equal to 0. So dismembers if the health is 0, it breaks if the health is below about 25% of what the uh, actual full health is. Um, then there's bool should simulate trauma, which is also an output to this function, which is based on the definitions should trauma be simulated bool. Then if all of this is successful, I return the replacement body part mesh, which is not a skeletal mesh component, but just the skeletal mesh that we're going to use to set the skeletal mesh component with. So moving back up to owner damaged, we use our output variables, hit constraint, fname for bone name. Bool should break, bool should dismember, and bool is trauma simulated. We set those here. So initialize, we now have, we don't set these here. We use these set variables to set our output variables for owner damage. So owner damaged has matching output variables. That's why they're named similarly but different. And constraint to break here will be outputted now. It's no longer null, as it would be set to null if it didn't reach this. So with these initialized from our find body part to replace, we can now set our impulse power, which I use to get map value from range, and I use input 0 to max damage and output 0 to max impulse. Max damage is like I think like 1,000 or something, and max impulse is like 10,000. And then damage is our actual value inputted for our input power. So that's why we clamp it with 0 to max damage. And we also multiply that by -1. So the reason I do that is because damage is likely a positive number in this case, and we want a negative number for our impulse because we're going to be impulsing him away from us. So then I initialize the impulse using safe normals and multiplying the magnitude of impulse power by for each axis multiplied by our impulse power, which is set by our map value. A little bit complex, but essentially I'm just setting an impulse magnitude. The impulse magnitude is then used to for our break constraint. And it's also used to add impulse at location on the character mesh if we didn't break a constraint. And this is also done when you hit an already dismembered bone. So if the part is already broken, laying on the ground, then you add impulse. So this is pretty much everything that's happening in blueprints right here, I guess. This is where I normalize, so get safe normal, multiply impulse power by our x and y values, and z is just always the same. That gets added to our trace start, and that's used as our impulse. This value is also used for our impulse on broken constraint. So it's very similar. Pretty much this part's exactly the same. Important part is break constraint, simulate all bodies below, and set collision profile. So I set the skeletal mesh of the component that we hit. So the component hit was found from our our if statement here using find mesh component dismember previously explained. And that we changed the body part. So the body part, new body part, is assigned from our dismember definitions, replacement body part mesh. So, for example, when we dismember the head, we're going to replace the head mesh with our replacement body part mesh, which is our new body part here. We set that collision profile to physics body because currently the components have no collision as previously set in initialize zombie. we set collision profile of all the components to no collision. So we set it to physics body when we drop it because we want it to not fall through the ground. Then we, on the character mesh, because these are pose leader components, we want to set all bodies below simulate physics on that constraint that we just that we're about to break. Right after we break the constraint. I don't actually know if the order of simulating physics and breaking the constraint matters, but I've always broken constraint after simulating physics. So breaking constraint, as I've said before, it breaks off a constraint, breaks a constraint off a gore mesh, and it doesn't really specify how it breaks because you're inputting a bone name. So I just want to clarify, it doesn't break off the bone from the skeletal mesh. It breaks off the physics body from the physics body for that skeletal mesh. So the only way to reset them properly is not reassigning the skeletal mesh, but completely resetting the physics state for that skeletal mesh, which is why nullifying the skeletal mesh, setting it to a null pointer when I deactivate the zombie is important because without doing this, it doesn't reset physics bodies of broken constraints properly. I can delete this because I do this at the start now. I used to have this down here after all of this, but because I'm returning the component hit inside here, and I don't want to return it null, but I still want to spawn effects. I just moved it up here. So I spawn hit effects whether I break off a constraint or anything. I just spawn blood when I hit a zombie. The else statement here. So this is what's happening down here. So should be broken, should trauma be simulated. If both of those are true, we simulate body on the character mesh, which is the first index, first component in our dismember components, which in this case is going to be our default character mesh. Do this one. So 0 is always the body. Yeah, that's kind of how it works. So if both of these are false, that's where our else statement is. So it should be dismembered. I also do check to make sure new body part is valid before actually changing the body part. So if this mesh isn't, sorry, where do I set new body part? Yes, if the mesh set here from find body part to replace was valid, that or invalid, sorry, not invalid but null, then I don't enter this. So then it'll check the else statement, which, yeah, as I said, is this. So if that's false, that's when else would be handled. Oh, sorry, I'm one step behind here. Should be dismembered. If should be dismembered is false, that's when I move to this. So that's what's happening on the else statement. If should be dismembered is false, or in this case, our new body part is not valid, then it will check to see if should be broken and is trauma simulated, which is here. Then what I do is I use the character mesh, which is the index 0. I simulate physics. I also set the collision profile to physics body rather than keeping that character mesh because I would rather have them as a physics body when ragdolled. So this is where I actually include self. So the one important thing here is you'll notice that when just simulating all body below physics on a body part, and we're not fully killing off the zombie or fully setting physics on the whole thing, then we don't want to include self. But when we are simulating it on the body, we do want to include self. So this will pretty much ragdoll the whole body. Then I do the check afterwards. So is simulating physics on the bone name. Now, the one thing here is they use the hit bone name. And the one thing they don't do. Oh, never mind. They do. Okay. It was just me making this mistake. The one thing I made a mistake of before is in C++, you don't actually have to input a bone name as specified here for add impulse at location to work. It will accept it without a bone name. It'll just default it to none because it's setting it to none by default inside here. So if you don't include a bone name, it doesn't do anything. So that was one mistake I made. And you'll end up getting a warning saying body doesn't simulate physics, or in order to add impulse at location, this needs to be simulating physics. So just make sure that you're inputting all the inputs when using add impulse at location. Otherwise, you might get some warnings. A lot of talking. So that's pretty much the iterations, challenges, and final version of my iteration with zombies right now. I did want to mention some of the things I would like to do in the future and show you kind of how zombies are working now. So start the first round here. Might have some bad frames while I can break off zombie parts when he is still down, which was another cool thing I wanted to make sure worked. They dissolve after a few seconds, so you can see, yeah, it was only simulating physics on these body parts, and then when they respawn now, you can see, I'm not sure if it spawned a new one or an existing one, because they're both working and the same now, so yeah, you can see I'm not really having any issues with just resetting physics and stuff, so it seems to be working good. Yeah, some of the things that I would like to add to these zombies is, like, they move really slow right now, you can see, which is probably, I just like that for testing things, but they will probably move only that slow for the first round, and then immediately they'll speed up pretty quickly as the rounds increase, which will make them much harder. The movement's quite fast on the character, which I enjoy, so I'd rather make the characters, or the zombies, faster to increase difficulty than make the zombies or keep the zombies the same and make the speed of the character slower, because I do enjoy the sliding, jumping, double jumping, stuff like that. So, and this is our advanced zombie, so you can see the textures are a little bit better. Kind of stuck. He's kind of stiff-bodied there. Make sure check that out. Okay. So yeah, it all works. Yeah, he's really stiff-bodied when he's falling down there. I should check that out. I shouldn't really be stiff-bodied like that. That's pretty much the only issue. The navigation of the zombies is quite, you can see, he's doing some weird stuff there, not turning towards me and stuff when he's attacking, so I really want to improve the zombie attacks, the zombie speeds, as I was saying, and the balancing zombie damage and stuff will be a little bit more of a challenge and come with playtesting, but I want to improve the zombie sounds, the zombie effects. The zombie animations are pretty good. They currently do jump up certain places, and that works. But I would like to improve the navigation system overall so that um, they don't just jump up to new locations, but they actually go to where they're supposed to, because that's currently what they that's currently what they do is they just fucking jump up in the air like that. So yeah, I have some fixes to do with the zombie navigation. I'm also adding new enemies. So if you stuck around for this whole video, you'll get a little bit of a sneak peek. I have what's coming is a hyena, which is kind of going to be like a little, I guess you could call it dog round, where it'll be, every 5 or 10 rounds, you'll have a pack of wolves come at you. Um, and then I have some flying enemies. So these little gremlin zombie looking guys. I guess he's not really zombie much right now, but I do have some better textures for him. Um, these will be used for uh, kind of just encouraging the player to keep moving. I have had some issues with the zombies not being able to get to certain locations, so the player can get up on a level that the zombies can't, which is kind of game breaking because then you can just sit there and just shoot zombies and camp there. So um, the gremlins will introduce a little bit of a bullet hell style um, into the game where these guys will just be shooting projectiles out of their mouth at you. Um, and they will be like homing projectiles, doom styled homing projectiles where you can shoot them, certain ones, not all of them, but you can shoot them so that they don't do damage to you. And yeah, they'll pretty much home towards you until they get really close to you, and then they'll kind of um, shoot straight at you, and you can still dodge them and stuff if you have time, or if you're sitting in the same location, you're gonna get hurt by them. That way, it encourages you to keep moving and stuff. And they will introduce a little bit more of a challenge because you'll have to not only worry about zombies on the ground, but worry about zombies chasing you through the air. So um, this will kind of help with difficulty, make it a little more challenging, and prevent players from camping, sitting in one location. The other one is Stickman. So Stickman's a little interesting because he's only going to be used in one location of the map. And this guy is going to be the maze protector. So um, you may have seen on the Steam page, there is a slight sneak peek to a part of the level I haven't fully finished. But it is working and it does have a huge intent for design and puzzle around the area of the level. So if you've been on the storefront, you'll notice right here there's a picture that comes up for a very short amount of time right here and right here of a maze. And that maze is going to be protected by this guy, a few of these guys, actually. Um, and, excuse me, the maze will be a little bit more difficult and horror styled, I guess you could say. I don't want it to be too scary, but scary enough that it keeps people interested and kind of wanting to go back there to find out new things about the maze. So there are hidden things with the maze, and I will say I've implemented some things into the maze inspired by the Maze Runner movies, which people will probably love. I don't want to give up too much as it's part of the puzzle itself, so you'll have to figure that out on your own. But the maze is huge. It's a big part of the level, and it'll be a big part of progressing in the survival mode. So there is somewhat of a progression system during the waves and during the whole game. So that'll be something to figure out. And yeah, the stickmen will be used to guard the maze. Um, they'll kind of maybe, I don't know, come around corners or come out of the hedges, stick their head out and then start chasing you or whatever. And they won't really be zombies. They'll more just be like an additional AI that kicks around. Same with the hyenas and the flying gremlins. They won't really behave the same way zombies will. Zombies have the whole dismemberment system and stuff like that, where these ones won't really have any dismemberment of any kind you'll have to worry about. They'll just have uh, they'll just have regular damage, and they'll kind of just catch on fire or float into ashes, explode or something when they die. Yeah, that's kind of a devlog for you. Pretty big update and a little bit of a showcase on what's to come with uh, Code Black. And for the more technical people, a little bit of a deep dive into how I've went through different iterations of code to develop the zombies and make them more optimized, and still have them based, very similarly off of a system that came from the Unreal Marketplace. So, if you're interested and you're using that system, and you have any questions for me, I'm more than happy to help and yeah, try and help you achieve something that I have. Thanks for watching, and wishlist Code Black on Steam. Otherwise, you'll have bad luck for 9 years.